Hello, and welcome to the Theory of Infinite Relativity!
I'm making this video simply because I don't have the academic training to publish an actual paper. I need y'all to help me get the attention of Neil deGrasse Tyson, Bill Nye, or like Mr. Maku. These are really the only guys I know, but they are my heroes. I love them so much. So, any physicist will do. I'd really like to work together with some physicists to make this into a reality, but God, I would love to talk to Mr. Neil deGrasse Tyson. You are the man. If you tell me I'm wrong, then I know I'm wrong. Your word is like God's word, and I will trust anything that comes out of your mouth within reason. Alright, so in this video series, we're going to be discussing several new ideas. However, the ultimate conclusion is that the speed limit of the universe is not actually 299,792,458 meters per second, also known as c, but rather that the speed limit is in fact objectively infinite. And from that conclusion, I offer a theory of infinite relativity.
Perhaps an even more stark conclusion is gravity. I really feel like I've solved it. I'm not just stroking my own ego here. I swear to God, you watch these videos, you tell me I'm wrong. I want to be wrong. I honestly want to be wrong, because if I'm wrong, then I can sleep at night.
Alright, so there is a lot to cover here, and so I'm going to be breaking these videos up into multiple parts, with each part building upon the last, so make sure you watch it in order. And essentially, the whole point of this video series is to further Einstein's special and general relativity. I'm going to build the foundation of what I call infinite relativity. This is a continuation of Einstein's theories and how it would apply within an infinite universe. I'm writing these videos under the assumption that the viewer already has a strong foundation of astrology and astrophysics. And I also am assuming that you have a very strong imagination to envision infinity. Oh, and don't be distracted by my personality and rugged good looks, okay? I'm just doing this to entertain you. Truth be told, I've read academic papers. They are boring as fuck, so if I can add a little bit of flair to make this somewhat more interesting, I'm going to do it for you. This is all for you. Talking normal's fine. There's nothing wrong with talking normal, but who doesn't like some good personality?
Hello, and welcome to the Theory of Infinite Relativity!
Alright, so to begin, we're going to start off discussing the megaverse theory. And I know this is a weird place to start, because we don't even know if it's real. At the same time, it needs to be discussed, just so we can build a concept of how perhaps infinity manifests. Now, there are several versions of the megaverse theory. However, at its core, it is the idea that our universe exists in a larger vat of space that contains other celestial bodies similar to our own universes in size. Now, in the same way that atoms come together to create our universe, perhaps our universe, in combination with countless others in the theoretical megaverse, come together to create an even higher plane of existence. And this pattern could rinse and repeat infinitely, where countless megaverses even come together to create an omniverse. And maybe omniverses exist in a higher plane, and so forth, endlessly. In this way, all planes of existence are contained within each other, and the third dimension could be fractally infinite. Like I said before, though, there are many versions of this theory, and for the purposes of our argument, it honestly doesn't matter which one is correct. All that matters is that we acknowledge more space exists outside of our universe. That's it. Which really isn't that hard to fathom, is it? And while it's unlikely that we will ever empirically prove, at least anytime soon, that space exists outside of our universe, there is, however, evidence within our universe that supports this theory. And this evidence is that our universe is expanding. The only logical thing the universe can be expanding into is more space. Think of our universe like a bubble. There is air inside and there is air outside. except our universe isn't a bubble. It's a force field. Now, at this point in our conversation, I think it's important to define a new term before continuing. A force field. Force fields in the universe are things like particles in the microverse, or the universe as a whole, or the megaverse as a whole, and so forth. It's a field created by forces operating within it. Simple as that. A star or a teddy bear is not a force field, but rather they are comprised of force fields. Make sense? All of reality seems to be created out of force fields that come together to create higher planes of existence contained within larger force fields. This is an important term that I will use frequently, so please remember what it refers to. Now, this is not to say that all force fields look and operate the same. I'm just trying to bring a definition to the phenomena that we're witnessing here. Alright, so let's get back to the conversation. If you need any extra proof that space exists outside of our universe, just think about how the fourth dimension of space-time is a fabric that the third dimension sits within. I mean, the fourth dimension, it's not length, width, or height. It's penetrative in nature, not limited to the boundaries of 3D matter. And it's because of this penetrative nature that 4D space-time is the same no matter where in the third dimension we explore. Whether inside an electron, inside our universe, out into the megaverse, I mean, it doesn't matter. The fourth dimension penetrates everything, inside and out, and it would be the same fabric no matter where in the universe we observe. And because of this, it just makes logical sense that space exists outside of our universe. Alright, so to conclude this video, I want to review the main points discussed so far. I'm going to be making a habit of this, doing this in every video, so that we can keep the conversation as focused as possible. Ultimately, we're going to be leading to a theory of infinite relativity. Alright? 1. Our universe is a force field-like structure, a field produced by the forces operating within it. 2. The physical third dimension sits within the fourth dimension of space-time fabric. And 3. Outside of our universe exists more space. I know. Heavy conclusion so far, right? Now, I know none of this is new information, but I have to present it because it's part of my theory.
Hello, and welcome to the Theory of Infinite Relativity!
So, what is gravity? There's a misconception that gravity is a force, but it's really not. It's a consequence. Gravity, as we generally understand it, is a byproduct of a third-dimensional object of mass distorting the fourth-dimensional space in which it sits. Something like a planet or a star distorts the space-time around it by contracting space-time. This creates a shrinking effect on the fabric of space, and a byproduct is attraction, where other celestial bodies will fall or be pulled closer together. Now, it is theorized that a massless particle known as a graviton may be at play. However, I'm not a big supporter of this hypothetical particle. All this will be discussed later. For now, let's just focus on mass distorting space. I'm going to discuss gravity in a very general, elementary manner right now, but as we progress, this conversation is going to get a little bit more complex. Alright, so let's continue. In science, we were always shown this image, but the external effect of mass on space-time actually looks more like this. This interaction occurs between everything in our universe, including planets, stars, galaxies, etc. Like, gravity is the glue that binds everything together. But something else to understand is that an object of mass is composed of like 99% space. And therefore, objects of mass do not just distort the space around itself, but inside the object of mass too. Which is why our planet, for instance, has different layers leading to a core, with each successive layer containing heavier metals. However, more than just penetrating objects of mass, like planets, stars, and teddy bears, I believe that space-time distortion also penetrates the force fields in which these items are actually made. Think about it. If there is an external impact of force fields occurring on the fabric of space-time, there's likely internal impacts occurring as well. I say this because the fourth dimension is penetrative in nature. So considering that the contents of any force field is mostly space, why wouldn't some interaction be occurring internally as well? And you're probably thinking right now, like, Adam, what the hell are you talking about? Like, gravity is a one-way street. No, it ain't. There's anti-gravity. So now this is where shit gets spicy. Listen up. We need to think about our universe as a singular object of mass itself existing in a larger vat of space, which I've kind of talked about being the megaverse. On the outside, our universe is producing regular gravity, distorting space-time in the megaverse. Okay? But on the inside of our force field, we can see that space is also being distorted. Space is expanding.
Now, I understand that we think that gravitons are the cause of gravity, inside of atoms and shit. But listen, it has nothing to do with a specific particle. Every single force field in the universe is a graviton. Like, for real, in my upcoming video on 4D magnets, I'm basically going to explain how every single force field in the universe has a positive or negative charge that constricts or expands space. And it's going to be unreal. But like I said, we have to talk about gravity in a very elementary way first. We're going to build into that concept of 4D magnets, okay? So just hold on to your pantyhose.
Now, this is a very bold conclusion to present, that space-time distorts around a force field externally and internally. However, so far, everything makes rational sense with evidence to support it, since we clearly see that space expands inside our force field. So, yeah, to conclude this video, let's go over the main points again. 1. Our universe is a force field-like structure. 2. Outside of our universal force field exists more space. 3. Our universal force field can be considered a singular object of mass from an outside perspective. 4. As a result of space being fourth dimensional, it is penetrative in nature, and therefore a force field's mass distorts space-time externally and internally. 5. External space-time distortion of a force field constricts space. 6. Internal space-time distortion of a force field expands space. Now, in the next video, we will discuss what the internal effects of space-time distortion are within our force field. I'm excited. This is where shit gets real interesting. Stay tuned, y'all.
Hello, and welcome to the Theory of Infinite Relativity!
Hello there! In the last video, we discussed that our universe, from an outside perspective, would contract space-time around itself in the megaverse, just like any star, planet, or teddy bear would. But what about space-time distortion that is occurring inside of the universe? Well, instead of a contracting force, we see that space is expanding. I do not believe the scientific community has come to this conclusion yet, so forgive me if I claim to be the first. However, have we considered that anti-gravity is the active force behind the expansion of the universe? I don't know, maybe. But I'm going to explain my thoughts on this anyway. The expansion of the universe logically needs to be a consequence of some interaction occurring. I mean, it's not like God did it. There has to be something logical going on. And here's what I think it is. At the time of the Big Bang, before any chemical interactions were taking place inside of our universe, the most primal of interactions that was taking place was our universe's mass distorting space-time. This interaction, in particular the internal distortion of space-time, is significant because it was through this process of space-time expanding that allowed the universe to cool, molecules to bond, and basically to create everything we see in front of us today. Without space expanding, our universe would still be in a very small hot state, with matter being super duper closely packed together. Where the mass of the universe came from, I don't know. Maybe that's where an idea of God comes in. So while we can't answer the reason why, we can at least observe how. And what we do observe about regular gravity is that it shrinks space-time. So if the universe is expanding, it logically makes sense that the cause of the expansion is anti-gravity, which expands space-time. Further, where regular matter creates gravity, antimatter, or dark energy, would be the culprit of the expansion. When we consider that there's like an estimated 95% of mass in the universe that derives from dark and antimatter, what else can we conclude? Now, something to consider is that dark matter is likely composed of dark particles, and there may be a whole nother side of reality we have yet to fully understand. Kind of like a yin to the yang of what we already see.
We're going to discuss dark force fields in another video though, so hold on.
So the question is not, what is causing the universe to expand? It is clearly a form of anti-gravity. No, the question is, why is the universe expanding? Why are we expanding and not just remaining the same size? Well, here's what I think's going on. Could be totally wrong, and it doesn't change a thing about my upcoming theory of infinite relativity, but I'm going to state my hypothesis regardless. The reason why anti-gravity is expanding our universe is because it is acting as a counteracting force against the regular gravity perimeter, or horizon, created by the universe's mass in the megaverse. Now, I know that was a mouthful, don't worry, I'm going to break it down. Essentially, the entire mass of our universe, matter and dark matter, was the same at the time of the Big Bang as it is today, which means that in the megaverse, our universe created a very large external gravity distortion around it. Our universe is still in its infancy, I think. And I believe it's expanding in efforts to accommodate its huge perimeters in the megaverse. Think about how a yellow star's gas is contained within a gravity perimeter as defined by its mass. When it burns off enough mass, it grows into a red giant. Similarly, I believe that our universe is also bound by a gravitational external perimeter in the megaverse, defined by its own mass. And so essentially what I'm saying is that the reason why our universe is expanding is merely a consequence of internal forces and external forces approaching equilibrium, where anti-gravity is the force of pressure that exerts itself inside a force field, and regular gravity is the force of pressure that exerts itself outside of a force field. Once the universe reaches full size and equilibrium is reached, the universe will likely remain in this state of maturity for a very, very long time before decaying. But I want to clarify something. Just because a final size of the universe is reached, doesn't mean this will stop space from expanding inside our universe. This is because dark matter will still be exuding anti-gravity, just like regular matter will still be constricting space. So don't worry, time will not stop moving once we reach full size. The only thing that will change is our universe will stop growing in size, because anti-gravity's pressure at this point will not be strong enough to expand the barrier any further than it has gone. So rest assured, time will continue and there will not be a big crunch. In fact, this big crunch is completely illogical. Think about it. The only way our universe will shrink is if regular matter is added somehow, creating extra gravity for a contraction. Or if dark matter is taken out, which would also disrupt the ratio and also lead to a contraction. Otherwise, the universe theoretically should remain a consistent size once equilibrium is reached. Look at other force fields. Take a look at an electron. It took probably mere seconds to come into being, but it stayed in its final state of maturity for a very long time. It's very likely the same thing that will happen to our universe.
Now, I do think at the end of time there will be a constriction. I just don't think it's going to happen in the way that we've thought about previously, where it's like an instant boom. It's going to be like...
As such, I believe that the expansion model of the universe looks like this. Now, while I obviously cannot prove any of this, since we have yet to observe dark matter, all I can say is that for me, all of this makes a lot of sense. Dark matter may not be the culprit of the expansion. However, it is the logical conclusion. Something in this universe is generating anti-gravitational effects, whether dark matter or otherwise. Now that said, dark matter is really just a term we're using to describe a phenomena. Something in the universe is creating more mass that we can't observe. Two forms of gravity exist. One is expanding space, the other is constricting. And we know mass is a factor in external constriction, so internal expansion would logically also be a consequence of mass distorting space. So for the purposes of the theory, while we don't need to know exactly what is expanding, I will be using dark matter as the term for it. Alright, that's it for this video. As usual, let's go over the main points. 1. Our universe is a force field-like structure. 2. Outside of our universal force field exists more space. 3. Our universal force field can be considered a singular object of mass from an outside perspective. 4. As a result of space being fourth-dimensional, it is penetrative in nature, and therefore a force field's mass distorts spacetime externally and internally. 5. External spacetime distortion of a force field constricts space, known as regular gravity. 6. Internal spacetime distortion of a force field expands space, known as anti-gravity. The purpose of these first 3 videos was to establish how perhaps infinity manifests. I mean, all that exists is matter and space, and so the infinite combination of the two allow for infinity. I believe infinity takes the form of force fields within force fields within force fields. This is the way I am conceiving it and is the way that I am presenting it. However, it doesn't matter exactly how infinity manifests. I'm just trying to help everyone understand how infinity could manifest. In the next video, we're going to be discussing the speed limit of the universe. This is like the beginning of my theory. Most of the world today in the scientific community believes that the universe is infinite. Well, if the universe is infinite, there's likely higher speed limits that exist outside of our universe, and therefore we need a theory of infinite relativity to accommodate.
Hello, and welcome to the Theory of Infinite Relativity!
Ooh, doggy, this one's gonna be a good one. So now that we have a general understanding of how infinity can perhaps manifest, it's time to discuss the meat and potatoes of this theory. And it all centers around the speed limit of our universe. It is known that the speed limit of our universe operates at 299,792,458 meters per second, a number often symbolically referred to as c. And nothing moves faster. This is also the same value for the speed of light. In fact, anything without a mass will automatically travel at this speed. C is also quite literally the speed of experience too. So as you can see, this number is probably the most significant number that defines our universe. Now, the speed limit may be c. However, I believe this to be true only within our universal force field. Outside in the megaverse or inside the particles of the microverse, the limit would be different. And to show how this is true, we will start by observing light, or rather, photons. Doing so will help us construct a better foundation to build from. We know for a fact that a photon is affected by space-time distortion, that light emitted from a star in a distant galaxy will twist, turn, and curve around other celestial bodies as it takes its straight path to our eyes. We also know that when traveling through various mediums like liquids, solids, or the vacuum of space, a light's speed will vary accordingly. However, where is the momentum coming from? What is accelerating the particle to see? Why is a photon not just sitting in place? Why does it move? Well, what if space-time distortion did more than just affect the path of light? What if space-time distortion quite actually defined the speed of light itself? And further, the speed limit of reality. Oh yeah, baby. Things are about to get real spicy. In the last video on anti-gravity, we discussed how space-time distorts outside force fields as well as inside. This internal distortion I have described as being anti-gravity, likely caused by dark matter. And it is expanding space-time from many points and in all directions of our universe. Now, something to understand about space-time expanding is that a consequence of the expansion is time dilation. When space stretches, time increases. When space contracts, like around a star or a planet, time decreases. which is why someone closer to a source of gravity will age slower than someone in the vacuum of space. This is all Relativity 101 though, so I'm not going to go much further into it. Let's continue. Now, I'm not sure if science has come to this conclusion yet, but I believe space is expanding at a rate of c, and the resulting time dilation slows all matter within the expansion to a specific speed limit. Now, that said, we do see that space is expanding faster than c the farther out we observe. And don't worry, I will address that soon. But for now, just follow me on this, okay? Space expands locally at a rate of c.
So now, when we think of a photon, the reason it is moving is because it is being carried along the currents of the expansion.
You see, with no mass to weigh it down, a photon automatically will travel with the expansion at the speed of c. In a very real way, the expansion of the universe is quite literally slowing the speed of light down to a rate of c. And I say that it is slowing it down to a rate of c because the speed of light is actually infinite. Being massless, its speed is limited only to the rate of expanding spacetime which propels it. All massless particles are capable of infinite speeds, and therefore the reason light is slowing down to a specific speed is because when space stretches, time increases, and so a massless particle like a photon will naturally travel at that dilated speed limit. Similarly, a particle that has some mass will still move along the currents of the expansion. However, its speed is slowed down by its own external gravitational impacts due to its mass. Which is why a particle of mass will never reach c, but a massless particle automatically travels at c. Alright, so what follows is also something I'm not sure science has actually concluded. All 3D mass in the universe is standing still. Photons, electrons, neutrons, dark matter, the Earth, Sun, galaxies, our universe as a whole, the megaverse, and so on. All of it. It's all standing still from its own perspective. What creates the illusion of movement is the interplay of matter distorting spacetime. Matter and dark matter produce fields of gravity and anti-gravity, distorting spacetime everywhere in the universe, tugging on and pushing against each other, and therefore constructing the reality we see around us. All particles are actually standing still though. Movement is an illusion of matter being carried along the currents of gravity. Oh, and if you're looking for any more proof that the speed of light is infinite, well, consider what we know about a photon's experience. From a photon's massless point of view, the instant it is emitted from a source, it instantly arrives at its destination. From our perspective though, it's traveling at 299,792,458 meters per second. But from its perspective, it's traveling at infinite speed. And the only way to explain this paradox is by understanding that both speeds are correct, and it is merely a 3D matter of perspective. Objectively, light's speed is infinite, but subjectively, from our relative perspective here within our force field of space-time distortion, we measure light's speed at a finite number.
And not only is the speed of light simultaneously infinite and finite, but it is also motionless, which is the biggest contradiction of all. A massless force field like a photon is capable of infinite speed, relative only to the rate of expansion that propels it. Given our specific location within space and our relative expansion rate, we therefore measure the speed of light at c. Objectively though, nothing is even moving, and all movement is just an illusion of space-time distortion. So in this way, all three speeds are technically true, and it's just a matter of perspective.
Honestly, this is such a hard concept to grasp, and it was hard for me to even know where to begin or how to end the discussion. I mean, I highly recommend rewatching all these videos again to grasp a fuller understanding of what I'm trying to say. However, I mean, for the time being, we're just going to move forward. Now, like I said before, some people might be thinking, okay, well, Adam, you say that space is expanding at a rate of c. However, this is only locally. I mean, space is expanding at a rate faster than c the further out we look into the universe. So why wouldn't massless particles like photons travel faster than c as well? And this is true. We observe space expanding at around 82 kilometers per megaparsec, a number that may not even be fully correct, as it was just recently thought to be 68 kilometers. But I want to make it clear that space everywhere is expanding at a rate of c. The reason we experience it expanding faster at farther distances isn't because it's objectively expanding faster. Rather, I believe it's a case of special versus general relativity. Here, imagine 5 stars in space, each separated by a megaparsec. If we are standing at the first star and we measure outwards, we'll notice that the things we measure that's closer to us will appear one way, and the things that we measure that are further from us will appear another way. So the reason we see space expanding faster the further we observe is because space isn't expanding from one center point outwards, but from multiple points outwards. And so as we observe farther, we see that space expansion is compounding from our perspective, appearing to distort faster and faster, giving the illusion that galaxies are moving faster away from us than c. But realistically, it's just multiple points of space all expanding at the same time. And as more space is revealed, matter and dark matter spread out into it, and the process continues. Therefore, locally, space expands at c from every point in the universe, which creates the non-local experience of space expanding faster than c when measuring at farther distances. To conclude this video, what we must take away is that the reason light is defined as c is not because this is how fast light objectively travels. It is because this is how slow light has been reduced to as a result of the anti-gravitational impacts expanding space-time within our universe. Because a photon is weightless, I believe we can reasonably conclude that light is theoretically capable of infinite speeds. We also need to understand that all particles stand still, moving along the currents of gravity. In this way, all particles are paradoxically moving and motionless at the same time, relative to one's perspective. And not just particles, but all force fields. We are at the center of the universe, watching it move around us. We are still from our perspective, but from an outside perspective, we are the ones that are moving. So, as we always do, let's go over the main points. 1. Our universe is a force field-like structure. 2. Outside of our universal force field exists more space. 3. Our universal force field can be considered a singular object of mass from an outside perspective. 4. As a result of space being fourth-dimensional, it is penetrative in nature, and therefore a force field's mass distorts space-time externally and internally. 5. External space-time distortion of a force field constricts space, known as regular gravity. 6. Internal space-time distortion of a force field expands space, known as anti-gravity. 7. Anti-gravity derives from dark matter, a term that encompasses any form of matter we cannot directly detect. 8. The anti-gravitational expansion of space-time has a consequence of time dilation. 9. The speed limit of any force field is defined by its internal expansion rate. 10. In our universal force field, our internal expansion rate measures at c. 11. Massless force fields, like photons, will automatically move along the currents of expansion at the speed limit. 12. Force fields of mass, like electrons, will move along the currents of the expansion too, but will be slowed further relative to their own external constriction of spacetime. 13. Massless force fields theoretically can move at infinite speeds, limited only by the spacetime distortions they operate within. 14. All force fields in the infinite universe are standing still from their own subjective perspective, moving along the currents of gravitationally distorted spacetime. 15. Movement in the universe is a matter of perspective. Alright, so before we move on to the implications of an infinite speed limit, we will be discussing dark force fields. I want to bring a stronger foundation to our understanding of dark matter in the universe.
Hello, and welcome to the Theory of Infinite Relativity!
Alright, we have made it to the final video. If anything I say has the capacity to change our understanding of physics, it's here. Now, I'm not going to lie, I might have some of the details wrong, but this is why I want to work together with someone, because the big picture in my heart and soul, it just resonates with truth. We're going to introduce a new term, dark force field. A dark force field encompasses all forms of dark matter. Unlike a regular force field that constricts space on the outside and expands space on the inside, dark force fields expand on the outside and constrict on the inside. And similar to how regular force fields exist at infinite scales, dark force fields too would also exist infinitely throughout the universe. In every plane of existence, these two opposing fields collaborate to create infinity. Dark force fields are just as relevant and prevalent in our infinite universe. Now, to save ourselves some confusion, from now on, the regular force fields I have been talking about this whole time will now be referred to as light force fields. Think about Star Wars. There is the light and the dark side of reality. Inside the light, expansion. Inside the darkness, constriction and death. And just like in philosophy, in the darkness there is light, and in the light there is darkness. Now, this is going to be a heavy conversation, and the only way to begin is with a metaphor. We are going to compare light matter and dark matter to a magnet. Magnets have a north and south pole. As we know, same poles repel and opposite poles attract. But instead of electromagnetism, we're going to imagine this magnet using gravity instead. On one side of the magnet is regular matter, which constricts space around itself. On the other side of the magnet is dark matter, which expands space around itself. And so, what I think is happening in the universe is that essentially light and dark force fields are acting like 4D magnets, but instead of distorting electric fields around themselves, they are distorting gravitational fields. Now, all this said, these 4D magnets do not look like this, where light and dark force fields independently contain opposite charges. Rather, every force field in the universe is a 4D magnet. Light force fields look like this, and dark force fields look like this. Force fields either constrict space on the outside and expand space on the inside, or expand on the outside and constrict on the inside. In this way, like force fields repel each other, and opposite force fields attract each other. Now, as I just said, like force fields repel against each other. So let's examine this closer. We will begin with dark force fields. How do dark force fields repel each other? Well, dark force fields produce anti-gravity, and therefore, it doesn't take a genius to conceptualize how dark force fields repel. I mean, space expansion is a natural separator. Therefore, two fields of anti-gravity would logically repel each other. The difficult thing to understand is how light force fields repel. Because, let's be honest, it seemingly appears that light force fields attract each other, not repel, right? Due to their gravitational constriction, it's our natural inclination to think that light force fields would attract to each other, kind of like how we see stars and planets gravitate around each other. But this isn't the case at all. In order to understand how light force fields repel, let's look at two of them. Each being a singularity, we can see that they never actually would touch, as space-time constantly is constricting around the singularities, preventing one from ever getting too close to the other. And if we observe the arrows, we'll notice that they're both going towards the singularity, and the midpoint of space between the two singularities is actually kind of expanding, isn't it? Effectively taking on an anti-gravitational effect. As such, light force fields will never touch. The reason we experience gravity the way we do on our scale, like with planets circling stars, is simply because all force fields which compose an object of matter are collectively constricting spacetime. They do draw objects of matter closer to each other, but the force fields which compose these objects will never actually touch. To conclude this section, like force fields repel against each other as a result of having similar gravitational fields, which distort space in ways that prevent them from ever touching. Now, concerning attraction, just like magnets, opposite gravitational fields attract, and we can observe this between light and dark force fields. Just look at the diagram. The arrows are all moving in the same direction, instead of opposite directions like it was for repulsion. As we can see, it's pretty obvious why these gravitational fields would attract. However, the question that needs to be asked is, what happens when light and dark force fields collide? Well, astrophysicists have already figured this one out. When a light force field comes into contact with a dark force field, they annihilate. Instead of saying force fields, we could say particles. When a regular particle comes into contact with an antiparticle, they annihilate. So, due to their opposite field charges, the fields cancel each other out, and a chain reaction occurs inside, where all the subsequent force fields that compose the prime fields in question also annihilate. What emerges are photons, or rather pure energy. Photons and antiphotons, as we know, are the same thing. They are neutral particles with neutral charge. As such, a photon is neither attracted to nor repelled by light or dark matter. Instead, it just moves along the currents of space-time distortion. To conclude this section, opposite force fields attract due to their gravitational pulls naturally bringing them closer together. I hope this clearly explicates how all force fields operate as 4D magnets, repelling and attracting each other. Because the ultimate conclusion here is that every force field in the universe is a graviton. All force fields distort spacetime internally and externally. There is no one particle called the graviton, rather all force fields constrict and expand space. Now, if the prior conversation was complex, it's only going to get more so from here. I stated that space constricts inside of dark force fields, but what does this mean exactly? What is causing space to constrict? Well, let's think about it. Consider how there is 95% dark matter in our universe compared to 5% regular matter. And because there is more dark matter, our universe expands. Well, in a dark force field, it's the opposite. We can imagine it as having 95% regular matter and 5% dark matter. Maybe not that exact ratio, but the point is that there would be a greater amount of regular matter inside compared to dark matter, and this would create a constriction of space-time inside dark force fields. You see, I believe each dark force field is kind of like what our universe was before the Big Bang. A whole bunch of matter, super duper closely packed together. In fact, before the Big Bang, our universal light force field may have actually been a dark force field. But regardless, inside of a dark force field, I think it kind of looks like that. There are a whole bunch of light force fields inside, and not enough dark force fields to create expansion. Now, I know that sounds perplexing, that inside dark matter is regular matter, but again, think of our universe. We know that our universe existed at a size smaller than a pinhead at one point. We know that matter can be condensed to incredibly small sizes. I think dark force fields are simply the consequence of a field that contains more regular matter to dark matter. It's no different than a regular force field, just the opposite. So what we need to take away from this section is that what makes a dark force field is that it has a greater ratio of regular matter to dark matter inside of it. It constricts space-time internally due to an abundance of regular matter. And this also explains why dark matter has mass. It's comprised of regular matter, or rather, light force fields. With all this said, there may actually be less dark matter in the universe than we actually think there is. If every dark force field contains a lot of regular matter, like a miniature Big Bang, then they are heavy, like very heavy. So in reality, the quantity of dark matter may actually be similar to the quantity of regular matter in our universal force field. But because it's so heavy, we simply miscalculated and predicted that dark matter particles outnumber regular matter particles. And I'm talking quantity-wise, not weight-wise. Weight-wise, dark matter clearly outweighs regular matter. But quantity-wise, it's very likely that the universe may be 50% regular matter and 50% dark matter, still allowing for an expansion due to the overabundance of weight, but being rather evenly distributed quantity-wise throughout the infinite universe. But honestly, who really knows? And who really cares? It's not even really relevant. I don't even know what I'm talking about. I'm sorry, let's move on. Now, we just discussed what dark force fields are made of, But I want to elaborate on photons, because photons are not exactly light or dark force fields. They are neutral fields. They have a neutral charge. They do not expand or constrict space. As such, we need to discuss them more to get a fuller picture of how the universe manifests. From now on, I will be referring to light as photonic force fields. A photonic force field, as we know, has zero rest mass, which means it is a particle always in motion. It cannot exist in a rest state. However, it never would be in a rest state anyway, as space-time is always moving everywhere in the infinite universe. As I described, all force fields are gravitons, and therefore at all infinite scales, gravity is distorting everywhere. Further, just like force fields, photonic force fields are also infinitely composed of smaller versions of themselves, infinitely divisible. I know we think photons are elementary particles, but let me try to explain this a little further. Currently, science believes that the whole universe is made up of energy. In fact, all particles are made of energy, all the same energy too. It's all energy just vibrating at different frequencies. Now, if photonic force fields are made of pure energy, and all other force fields are assumed to be composed of pure energy, I think it's a fair assumption to conclude that all matter is really just light existing at different densities. It is the raw substance that all force fields are made of. Now, I'm not going to go too much further into this because it is almost irrelevant and not super important, but I think it's just interesting to discuss and to conclude. I mean, think about it. There's three fundamental fields in the universe: photonic, light, and dark force fields, all represented by the primary colors. They have positive, negative, and neutral gravitational charges, and these three fields manifest at various scales and construct all of reality. Now that we understand all force fields as being gravitational magnets, it is time to discuss mass. And in my mind, based on everything we have discussed so far in these videos, this could be the most significant. The question should be asked, where does the mass of a force field come from? Mass itself, the thing that causes weight. What is it? We've heard of the Higgs boson field, however, I'm going to offer a simpler solution. I believe mass doesn't emerge from a field or particle. Rather, all force fields have mass, as determined by the force fields that compose them. Allow me to explain. Light force fields are made of smaller light and dark force fields, and these smaller force fields are also 4D magnets, constricting and expanding space. This space-time distortion occurring inside at smaller scales is the culprit of mass. Consider an atom. The more electrons it has, which remember are also force fields, the heavier the atom is. The more electrons an atom has, the more space internally constricts inside the atom. And therefore the external path that the atom takes through our universe is slower due to its internal constriction. You see, mass of any force field at any scale is determined by the number of force fields operating within it. The more inner force fields a prime force field has, the more space-time will distort. And so, as a result, what happens when we experience weight has nothing to do with the object actually having a weight. It all has to do with gravity. Mass is ultimately an illusion. It is a product of how intensely internal force fields distort space-time, which slows the movement of the external force field's path. Now, do you want more evidence that mass is an illusion caused by gravity? Well, everything is technically weightless in space. There's your proof. Weight is an illusion we feel as a consequence of being between two objects of mass. You see, weight is the consequence of the resistance we feel when we try to prevent the gravity of one object pulling the other towards itself. Think of it like this. We exist on Earth, and gravity will naturally pull anything closer to the Earth. The resistance we feel when we hold an apple, it isn't the apple itself containing weight. Rather, the weight we feel is just the consequence of space-time pulling the apple towards the Earth. You experience weight because you are resisting the apple from falling towards the Earth. If we replace the apple with a 100-pound dumbbell, space-time is shrinking faster making its gravitational pull towards Earth more intense. Think of the dumbbell and the apple like magnets. The dumbbell has a greater gravitational intensity than the apple does. Now, to solidify this idea, think about how when we drop two items of different weights, how they both fall to Earth at the same speed. Why wouldn't the dumbbell fall faster? Well, they fall at the same speed because gravity constriction is similar to anti-gravitational expansion. For the same reason anti-gravity expands at a consistent rate of c, not faster, not slower, regular gravity emitted from light force fields also constricts space at a consistent rate, not faster, not slower. You see, all stars, planets, and teddy bears have constriction rates based on the quantity and quality of the force fields that compose them. And as such, a dumbbell or an apple will fall towards Earth at the same speed because of the Earth's defined constriction rate. Therefore, the rate at which the apple and dumbbell fall is not determined by their mass. It is determined by the Earth's gravity. Now, this is a very difficult idea to get your head around, so please, do your best to understand it. Because what I'm ultimately saying is that all that exists in the universe are expanding and constricting force fields, and all force fields act as gravitons. The degree to which these force fields constrict space is the degree to which mass is measured and observed. But ultimately, mass doesn't exist. It's an illusion of gravity. And the only reason we say some particles weigh more than other particles is simply a result of their inner constructions having more gravitational constrictions happening. Which is why an iron atom is heavier than a hydrogen atom. It has more force fields inside of it constricting space, which therefore slows its movement through our space-time experience. Oh, and one last thing. Concerning photonic force fields, the reason they are massless is because they are neutral in charge, having no gravitational properties. Mass is an illusion of gravity. I don't know how many other examples I can provide here, but if all this doesn't make sense and add up, I don't know what will. Oh, this part is good. I'm excited for you. Okay, so I'm going to make a bold claim here, which is my theory of everything. Earlier in this video, I discussed how every force field, light and dark, in our infinite universe acts as gravitons. They are all 4D magnets. Now, if the universe is a progression of infinite light and dark force fields within force fields, matter distorting space is the one fundamental consistent operating across all time and space. Something and nothing is all that exists. The interaction between the two, i.e. gravity and anti-gravity, is what moves the universe and shapes its form at all scales. Without matter distorting space, there would be no momentum in the universe. Everything at all scales would be at a standstill. In fact, the universe wouldn't have been able to coalesce into anything. Absolutely nothing would take form without matter distorting space. And so, in this way, the universe takes on a beautiful dichotomy, where mass shapes space and space shapes mass. This is how our whole infinite universe takes form. And so my ultimate conclusion is that at varying scales, force fields distorting space-time is the one consistent feature of our universe. The primal force of the universe that everything else builds from is gravity. Mass is an illusion of gravity. Time is an illusion of gravity. But not just mass and time, but the fundamental laws of nature themselves emerge from particles, which they themselves came into form through gravity. Gravity is responsible for the formation of the universe at all scales. When we conceptualize light and dark force fields as gravitational magnets, we can now understand how the universe takes form at all scales, and further, how the three fundamental forces of our universe, and all unknown forces yet to be discovered in the mega and microverse, all manifest as a result of the primal force of gravity. At our scale, we have particles that produce Newtonian physics, but in the megaverse, new forces likely exist, as determined by the constructions of the force fields inside of it. For instance, our universe may quite actually be a force particle. Our universe may actually produce a force distinct from the three that we witness inside of our universe. Similarly, the quantum physics we observe in the microverse likely belongs to a set of forces we have yet to discover, due to the force fields which construct them being way too tiny to observe right now. In this way, different planes of existence contain different sets of physics, all defined by the forces and force fields which construct the plane. Without quantum physics operating in the microverse, Newtonian physics wouldn't exist on our plane. And without Newtonian physics on our plane, whatever physics our universal force field creates in the megaverse would also not exist. All forces build upon each other, and in this way, we can understand how the universe now evolves. It evolves infinitely through forces, emerging from force fields at various scales. We see evolution occurring on a small scale, so why wouldn't the universe be evolving as a whole? As above, so below, right? I mean, if the universe is infinite, how else could it accomplish infinity if not through the forces? With an infinite combination of forces, we can understand now how any reality we imagine, even ones too bizarre to work with our set of forces, is actually possible and makes perfect mathematical sense if the universe evolves through infinite forces. A reality with puppets who speak English? The Marvel Universe? Or my favorite, Doctor Who and Star Wars? It's all real. These realities all exist at some location in the infinite universe. Do we understand now how gravity quite literally defines our universe? How it creates momentum, how it creates time, how it shapes the forces we experience, how without space-time distorting, there would be no movement or no structures? Gravity is the primal force of the universe. Now, I know I squeezed a lot of information into this video, but I want to conclude with perhaps my biggest conclusion of all, and that is that our universe is a hypersphere. No, seriously, think about it. What does a fourth dimensional hypersphere look like? Spheres within spheres within spheres. Or in the case of our universe, force fields within force fields within force fields. If we stepped outside of our third dimension and looked at our infinite universe as a whole, it would look like a hypersphere. We see spheres in our dimension because we exist within it. But outside this infinite process, I'd bet my life that we are living inside a 4D hypersphere. And there may be other hyperspheres that exist. I have a lot to say on dimensions, so I won't talk about it all now. But because this is my big grand finale, I want to at least include it in this video. Because, I mean, it's what we've been talking about this whole time. Force fields. Force fields within force fields within force fields. The hypersphere is just something I had to conclude this video with. Alright, as usual, let's go over the main points. However, this time, I'm just going to show them in a picture. Alright, you can read them yourselves. I recommend pausing the video, because I have already spent almost 25 minutes on this, and we need to end it at some point, and I don't have time to spend 2 minutes reading all these.
Now, after all this has been said, you have to keep in mind, I am not academically trained. I am a connoisseur of astrophysics. I love it, but I don't know a lot. Okay, so lots of the details here, I acknowledge, are probably wrong. However, perhaps you can see the big picture here of gravitational magnets and how gravity is the primal force of our universe. So while even though some of the details may be wrong, I hope Neil deGrasse Tyson reaches out. Man, I love you. Please reach out to me. And yeah, also take another physicist. That's fine too. I'm cool with that. But Neil, please, dude, please. Well, everyone, that's it. I hope you enjoyed, and I'll see you in the next video.